Okay, in this section we're going to be talking about relative extrema, except I just want to go over finding extrema if we were on an open interval. Now in the previous section we talked about finding extrema on a closed interval, and so I just want to briefly give some examples of extrema if we were actually on a open interval. So here's our function f of x right here, which we're just looking at the graph. Now, the relative extremas would be, for example, this would be a relative extrema here. This would be a maximum, and this would be a minimum down here. And of course, because we're on an open interval, this could not be a maximum up here. We can get closer and closer to B, but remember we can never actually reach B because that's what the parentheses here indicates. So relative extrema, this would be a max, and this would be where the relative minimum would occur. Okay, let's look at this example here. We've got the graph here of g of x, and a, right? This, of course, a now is on the x-axis, which I don't actually have it written out here, and b is also on the x-axis. But the minimum in this graph would occur here. Now the question is, does this have a maximum? And the answer to that is no, and that is because we have parentheses here, which means we don't actually include the endpoints. Okay, we do not include, for there is not a maximum. Okay, h of t, and this is the graph of h of t. This time I've got a bracket here filled in, but there's a let's fill this dot in right here. Okay, actually I went ahead and put parentheses around AB, since that's what we're talking about here. But this graph doesn't have a maximum or a minimum, and the minimum would normally occur here, except we have a missing point in the graph. This is where it's not defined. We could get a critical number here, but we can't get a max or a minimum. I'm sorry, because this is undefined right here, and where this dot is. This open circle right here is actually where I'm considering to be the actual where the minimum would occur. So this graph has neither a maximum or a minimum. Okay, so we've got the graph here of f of x. As you can see here, we have open circle on both ends, so this graph doesn't have a maximum. But what about a minimum here? Well, as you can see here, this dot actually represents the minimum. So the minimum would actually occur right here where you can see that this filled in is located. Now if this filled in circle was up here, then we could say that this of maximum. Let's say that that filled in circle is actually right here or here, right, or here. Okay, so this would have a relative maximum. But this graph actually has a min, and it doesn't have any maximum.